In this lecture, I will be discussing the properties of melting points. Melting point of solids is a useful tool in helping to identify compounds as well as determine their purity. Solids melt when the temperature is raised and the tightly packed crystals of a solid start to break apart into liquid form. This can be seen as the melting point of the solid. On this slide, you can see the assigned reading material for this section. I highly recommend that you guys please read the textbook. You may find things in there that you may not get from the lecture, and it's always useful to get more information from there. The melting point of a solid can be defined as the point at which both the solid and the liquid coexist at equilibrium. In other words, think of it this way. With ice water, you have both ice as a solid form of water and liquid water together. In fact, if you take the temperature of this, you'll find out that the temperature of the water is in fact close to 0 degrees Celsius, which is the melting point of ice. Another definition of the melting point is the temperature at which the vapor pressure of the liquid and that of the solid are the same. Vapor pressure is basically the pressure that a solid or a liquid exert on the pressure of air. As I mentioned earlier, when solids melt, the energy of the attractive forces is overcome by the kinetic energy of the molecule due to the rise in temperature. The melting point of a solid is actually more of a melting range. You will realize that when a substance is melting, there's a beginning temperature and the final temperature. These two temperatures are known as the melting range. So you'll notice when you have a pure compound, the melting point is actually a much sharper range, usually around 1 degree difference. However, if you start having a mixture of compounds, you realize that you have a larger range of melting temperatures. So it's about a difference of 2 or 3 degrees Celsius. Another thing to mention is that when a compound is mixed with another compound, the melting point of the two compounds together is lower than the melting points of either of the two pure compounds. This is known as melting point depression. On this slide, you can see an example of what I mean by the lowering of the melting point. You'll see here you have two substances with different ratios. This is mole percentage of A, and this is mole percentage of B. At 100% A, you'll see the melting point of A is this A in the brackets right here. However, having an additional impurity, which is B, you have here 20% B and 80% A, you'll notice the temperature of melting is actually lower, which is C in brackets. And you'll see the same thing happens with B here, right? You have 100% B, 0% A. This is the melting point of B. However, adding 20% A lowers the melting point down to bracket D. So you'll notice right here, there's a minimum temperature at which the two solids melt. This is known as the eutectic point. The depression of the melting point depression is at its maximum at the eutectic point. This is what this bullet means right here, the maximum melting point depression. Now you'll notice here the eutectic mixture of ice and salt is 77% ice and 23% salt, and the temperature is minus 21 degrees Celsius. This is exactly why during winter, when the roads are iced over, they throw salt into the roads to make sure that the ice stays liquid. The experiment used in these labs involves finding the melting ranges of a mixture of two compounds. One of these compounds is benzoic acid here. You'll notice it's an aromatic ring with a carboxylic group. I don't know if you guys are covering your functional groups yet, but this is what it is. You'll see here the melting range is 121 degrees to 133 degrees Celsius. You'll see it's a white crystalline solid. Here you see naphthol, which is aromatic bicyclic ring compound with a hydroxyl group, which makes it an alcohol. You'll see here, this is the range. The temperature is 121 to 123 degrees Celsius, and it's a brown solid. So 5 samples are prepared. One of them is pure benzoic acid. Another one is approximately 10 to 90% naphthol to benzoic acid. And it goes on with different mixtures until you have the 5th one, which is pure naphthol. You'll see here, these are the melting point capillary tubes. These, they look big in this picture, but in reality, they're really, really tiny. These are filled with compounds with these 5 different sets, and they're filled up like this, right? So it's like a little test tube, and you fill it up with your powder right here. You can see that. Try to put it down as far all the way down to the bottom, and you want to tap it down. So this you'll see right here, right? You don't want to add too much because then a lot of it won't melt. So this is how it's done. So once you have put your sample into their capillary tubes, you move on to this machine right here. This is known as the melting point apparatus. This is one of the digital fancy ones that are found in the undergraduate labs. You'll see here there's a set of instructions for how to use them. They have automatic ramp rates and all of those things. You'll notice here there's a little glass to view the sample, which is like this. And there are 3 little slots where you can put your capillary tubes. So they're hard to see here, but you can put them right there. You want to start off by having a quick ramp rate so you can reach close to the temperature that you need. Then after that, you change your ramp rate down to about 1 degree Celsius per minute. And you'll start recording temperatures. So you start recording once it starts looking like it's kind of turning into liquid. You'll see little drops falling off this solid here. And then you'll start noticing that there's more and more liquid, and you see what is known as the meniscus, which is the compound climbing up the sides of the tube due to interactions between the glass and the compound. And then the final temperature you record is when all of the solid is gone, and this will be your melting range. If you were to have actually performed this experiment, you would have obtained a set of data right here. And so you would use this data having your names of your compounds here, and the melting point begins right here, and the ending melting points right here. And then you would just plot them in Excel, and you'll notice that familiar shape of the V right here. Obviously, you guys are not coming into lab, so you can't really do this. I don't know if Dr. Mighty might make you guys do something just for homework or whatever, but this is how you would do it. I don't know if you guys know how to use Excel, but it's a really nifty app to make really cool graphs like this. Upon finishing an experiment, if you were to be at the campus, you would make sure to dispose of your benzoic acid and naphthol and anything with a lot of contaminated paper or anything into the solid waste container. If you used capillary tubes, they would go into the broken glass container. And of course, you would want to make sure to turn off your Digimelt apparatus for the next class.